Hello. The lab performed in this video is two-dimensional motion projectiles.
The question is, what is the range of a projectile launched horizontally? The materials you will need in this experiment are a data collection system, a Pasco SmartGate PhotoGate, a Pasco mini launcher, a Pasco PhotoGate mounting bracket, a launcher loading rod,
A mini launcher table clamp, a steel ball 1.6 centimeters in diameter, one sheet of white paper, one sheet of carbon paper, cardboard square piece 10 by 10 inches, and a meter stick. Next, develop a hypothesis to accurately measure the variables that affect the two-dimensional motion of a projectile launched horizontally.
Measure initial velocity with repeated trials for accuracy, holding height or delta y constant in order to predict range.
Our two independent variables are launch height, which is our predicting variable, and initial velocity.
Launch height will be held constant, but our range is our dependent variable. Connect the PhotoGate mounting bracket and PhotoGate to the mini launcher.
Choose a corner of the table to mount the projectile, and make sure you have 3 meters set for your projectile.
This has already been set up.
Next, connect the PhotoGate to the data collection system like SparkView. Make a chart of velocity between gates and time.
Configure the data collection system to use the PhotoGate timing to measure the initial speed of the projectile passing through the PhotoGate, and then display this measurement in a single digits display. Measure the height of the position in which the ball will be launched. The value used in this lab is 0.98 meters. Record it in your data table.
Next, make a target of 8 centimeters in radius. Then you will take a piece of carbon paper and lay it carbon side down across the target.
Next, you have to load the steel ball inside the launcher and then put the pencil until you hear 3 clicks. 1, 2, 3.
Next, in order to test the initial velocity to find the range, put a piece of cardboard or a very heavy book in front of the launcher and record data to find your initial velocity. Repeat this data collection 4 times.
Now that you have found your range, place your target and carbon paper on the floor where the position was indicated. After you've completed all your trials, you will remove the carbon paper to see where the ball landed on the target.
Start collecting data and then launch the steel ball. I think that was good.
Great.
That was good.
Awesome. Thanks for almost hitting.
Yes.
Super sick, Carol.
Nice!
No.
Yes. Repeat this 4 more times.
Yeah. Observe the locations on your target and define them with the accuracy and precision charts in your lab packet.
Add up the initial velocities for the 5 trials and then take the average of those velocities and then fill that in that blank.
And then use your average launch velocity and the measured height, which was 9.98, and calculate the range of the projectile using the equation found in your lab packet. Assume that gravity is 9.81 meters per second squared.
Using the given table, our data is found to be both moderate in precision and accuracy. Factors that may have caused our range prediction to be incorrect include not using the exactly 3 clicks to load the ball, making inaccurate measurements, and having things in the way of the path of the projectile. These problems can be improved by using a partner to double check or make second opinions, as well as by making sure to have 3 meters or more of space for the projectile. In conclusion, factors that affect the range of a projectile launched horizontally include its initial height and its predictable unknown initial velocity.